Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Nucleophilic aromatic substitution, SNAr. The reaction of aryl halides with OH ions proceeds via SNAr mechanism. The rate-determining step is the addition of the nucleophile to form a mesenhymer complex. Electron-withdrawing groups, EWG, at ortho and para positions stabilize the mesenhymer complex and increase reactivity. The number and positions of nitro groups relative to the leaving group, Br, determine reactivity. Moving on to the next step. Identify the structures and count activating nitro groups at ortho-para positions relative to Br compound I-M-nitrobromobenzene, 1 number to group at meta position. Meta number 2 provides inductive withdrawal but does not directly stabilize the mesenhymer complex through resonance. Least activating arrangement. Compound 2,2,4,6 trinitrobromobenzene, 3 number 2 groups, 2 at ortho, 2, 6, and 1 at para, 4, relative to Br. All 3 are at ortho-para positions, maximum resonance stabilization of mesenhymer complex. Most reactive. Compound 3, p-nitrobromobenzene, 1 number 2 group at para position. Para number to directly stabilize the mesenhymer complex through resonance. More reactive than meta. Compound 4,2,4-dinitrobromobenzene, 2 number 2 groups, 1 at ortho, 2, and 1 at para, 4, relative to Br. Both are at ortho-para positions, strong stabilization. More reactive than monosubstituted but less than trinitro. Moving on to the next step. Rank reactivity. 2, 3 number 2 at OP, 4, 2 number 2 at OP, 3, 1 number 2 at P, I, 1 number 2 at M. This gives the order 2, 4, 3, I. And for the final step. Match with options. Option B 2, 4, 3, I matches exactly. Why other options fail? A. I 2, 3, 4, completely wrong. More nitro groups at OP increase reactivity, not decrease it. C. 4 to 3 I, wrong, 2 has more OP nitro groups than 4 and should be more reactive. D. 2 4 I 3, wrong, 3, P, no 2, is more reactive than I, M, no 2, because para position directly stabilize mesenhymer complex via resonance. Therefore, the correct answer is B. Therefore, the correct answer is option B.